Hello everybody and welcome to this tutorial. Today I will be talking about packet analysis. Before I actually began recording this tutorial, I had a live capture session running and I made a request towards a random website. That random website apparently was I Love Cookies. Here in this list there are a lot of HTTP requests. As you can see, I have specified my filter to be HTTP as those are the sort of packets that I would like to analyze today and to show you what sort of useful information can you extract from them. So I'm just going to go ahead and click on the first one. So it's get HTTP 11. And we're no longer going to need the upper window or the upper pane, whichever way you want to refer to it. So I'm just gonna maximize this one, that we have a better overview of all the things that we're going to see here. So first off is frame. We're not going to be dealing with this, as you as a network admin generally won't be extracting information from this layer. In any case, this is the physical layer. Remember when we talked about the OSI model, this is the physical layer. I don't know, this gives you, look, it's just look at the title, 285 356 bytes on wire. So that's not really that interesting to us. We're just going to go ahead and click on Ethernet 2. By the way, Ethernet 2 is a standard. That's a name for a general standard used worldwide. Right after the comma, it says SRC, and I don't know, then it says then some sort of a name is written. It says HUN-HI, PR, underline, and then a portion of a certain MAC address. But that's besides the point. Right next to it, the next line, see, I'm just going to go ahead and click on it so you can see it better. It says BC8556 and so on and so forth. That is the MAC address of my network card, of my wireless network card. And right next to it you have DST, some name again, and then you have another MAC address. It goes something along the following lines: 00:0E:8F, and so on. You can read the rest. That is the MAC address of my router. My router is a point that I use to access the internet. So all my traffic that goes outside of my LAN network has to go through my router. And this is a very useful way of pretty much figuring out which devices are communicating on the network without knowing their IPs. So you can just have a look at the MAC addresses and you can know who is communicating with who. Aside from that, the first three sets of hexadecimal numbers within MAC addresses can tell you who the producer of the device is, who made the device, which company. This sort of information you can just browse on the net. It's fairly easy to find. You won't have any difficulties there. So we're just going to go ahead and close Ethernet 2 and dig into Internet Protocol, so IP. Internet Protocol version 4, there's also version 6, just so you know. And once again we have SRC as source and DST as destination. Just going to go ahead and mark it for you. There you have it. So I am the source, 192.168.1.2, and the destination is, this time the destination IP address is not my router. This time for HTTP request, the destination IP address is 198.252.73.207. That is the IP address of the website whose domain name is ilovecookies.com. It has already been resolved. We are not analyzing DNS packets here, rather instead HTTP packets. And if I just scroll down below, there is a ton of information here. I don't know, you have version, header length, total length of the package, and so on and so forth. But what is interesting to us is down here you can see that the protocol being used is TCP, and below it you have source and destination IPs. But once again, just go one more field below and take a look at what I've marked now. It says source GeoIP and destination GeoIP unknown. This is not because Wireshark cannot determine these two. This is not because Wireshark cannot determine the geographical location or something of a kind. Rather, instead, this is because I have not configured Wireshark to interact with any of the databases containing such information. And so if not configured, Wireshark is just going to give you unknown. I do not know where this IP belongs, to which country does this IP belong to, or to which city, or something of a kind. I'm just going to go ahead and close that. And now we're going to dig down into the Transmission Control Protocol, or TCP. Lots of information here once again, but I just want to stick to what is relevant to us at the time being. You have SRC port once again, and DST port. So they are right here where I have marked them. And destination port is HTTP port 80. That's all fine. We know what that is. But as you can see, before it you have the source port, and the source port is 40,131. So what on earth is that? What is that? Now this is not the port on which we are listening. This is the port on which we are transmitting our information towards the destination port. The source ports are randomly generated by our machines, and they can be pretty much any number within a given range. So yep, there we go. Let me just minimize this. It has escaped a bit. And finally we go into the text part of this conversation, of this request, so to say. So we go into Hypertext Transfer Protocol, or HTTP, and you can see the method is get. Down below, yep, there we go. Request method get. Path to the URI is backslash in all Unix systems, everything that's Linux based, and every other system out there except Windows is basically a marcation for a root folder. And that is the folder that we are requesting from that web server. In Windows, it's backslash. So this is just a bit of information unrelated to Wireshark if you are curious in that regard. Down below, we can see that the host is www.ilovecookies.com. But here's some interesting information right below the host. This is the sort of all of this you are transmitting to the web server, and sometimes this sort of information you don't really want to give away, you don't really want to transmit. So it says user agent Mozilla 50. It says that I'm running Linux on a 64-bit architecture. So the web server to which I made the request knows that I am running Mozilla, that is my browser. It knows the version of my browser, it knows my operating system, and it knows my processor architecture. If we go further down below, we see that the language that I'm using is also being passed. This language will always be the same as the one that is configured in your browser. So the default language of your browser will also be sent. This is one of the ways in which websites can determine which language should they display to you as a user by default. But that's not what they usually use these days, as far as I know. They tend to use IP addresses. So if you have an IP address that is coming from a certain country, the layout of the page, the page itself, it will display in the language of that country, which can be annoying, really annoying from time to time. But there are workarounds. There's some you can go about things there. It's not that complicated to bypass such mechanisms. And plus, on top of all that, you have add-ons for pretty much all the popular browsers out there, which enable you to actually modify this information. So I don't know, instead of this being user agent Mozilla, it can be Chrome or something like that, while in fact you're using, I don't know, Internet Explorer. So there are these add-ons which can fake information here and transmit it should you wish to do that. No harm there. It's just something that you can play around with. In any case, that would be it as far as this particular package is concerned. We will analyze a great deal more in later tutorials, but I just wanted to give you an idea of what sort of information can you extract from these individual packages. Later on, as we progress, I will create real scenarios and exercises which we will do. I will create problems for us to solve, and we will see how we can use Wireshark in order to track down particular problems on the network. But for the time being, I bid you all farewell, and I thank you for watching.